So hello everyone. For today's last session, we'll be installing FlexRIC and OpenAir interface. We will see how to deploy a 5G network with this framework, and maybe after the other short break, if we have one, we'll see how to deploy the X apps, and we will get hands-on with one of the X apps. Try to send a control message from the near real-time RIC and try to the RAN so that the RAN can act on that control message. So yeah, we'll see how much time we have left and what we can do. So depending on that, we can uh, adjust adjust our objectives. That's fine. So I want to talk a little bit about FlexRIC, but just to give an overview about how the framework is designed. But before I do that, let's just get started on the installation process so that when it's getting installed, I can talk about it and we don't waste much time. So whatever you have should be fine. The VMs that you have, uh, these work on top of that. So I don't think you will be facing any uh, conflicts with respect to that. So let's just get started. Yeah, and like Josh was saying yesterday, it's helpful to have both of these in a split window kind of format so that you can just copy paste the commands. So we'll install the dependencies first. Yeah.
So for Python dev, that package installed in Python 2 dev, is that what we want here?
Yeah,
Okay.
that's fine. We also install Python 3.8, so it should be fine. It's more of a safety net. I don't think they use Python 2 anyway, or Python dev anyway. So I'll wait for everyone to complete. So is anyone still executing this, or is everyone done with it? Just by show of hands, is anyone still executing this? Okay. Yeah, I'll talk about Swig in the meanwhile. So FlexRIC allows you to build XApps in two languages, Python and C. C is the more popular one, the one which has more support. Yeah.
GCC 9 okay?
Yeah. I think most of you will have GCC 9. That should be fine. Anything other than GCC 11 should be okay. Yeah. So Swig is basically a framework which implements or translates, yeah, to loosely say, translates the C functions into Python code. Uh, so that they don't have to do it from scratch, start from scratch. But we won't be needing it, but it is still a dependency for the FlexRIC module. So we will have to install it. Though we won't be using it, we'll need to install it. So let's clone the Swig repository. So there is a restriction on the version that you can use. So it has to be at least SWIG 4.1. But if you use the package installer directly, that will install 4.0. And FlexRIC is not compatible with that. So that's why we are cloning the repository and building it from scratch. Yeah, this is a pretty standard installation procedure. Clone the repository and just compile it using make. Yeah. Yeah, after everyone's with me, I'll move on to the next step. So how many of you are still? Is everyone done? Are you having a problem?
Taking some errors
I think, yeah.
without.
You didn't copy the whole thing, I think. These.
Maybe,
Oh,
I think. I
yeah.
just added more.
Yes.
Okay, sorry, man.
Sorry, man. I figured it out at the last minute.
Okay, nice.
Yeah, now it should.
I'll do it again.
Yeah. Yeah, we'll just make sure that the GCC version is fine. If it's GCC 11, then it doesn't compile properly. We'll get some errors. So yeah, 9 should be fine. 9, 10, 12 should be fine. Yeah, so when you install the OAIC RIC, uh, you install Docker and Kubernetes, but Docker Compose was not installed with that. So you can think of Docker Compose as an equivalent kind of sorts to Kubernetes, an alternative to Kubernetes, where you can control the deployment of your containers in the system. So the OpenAir interface core network uses that. So we'll go ahead with that, and it shouldn't take long. Yeah. Is anyone using a fresh system here? Like a new instance of Ubuntu? No, like a new 20.04 system. Okay. Yeah, in that case, you would have had to run a couple more steps.
On my version, you don't want to do sudo docker compose dash version, it's sudo docker dash version.
I think it's dash version. I think that's a typo there.
Space version?
Yeah, I think that's a typo there. Yeah.
Okay. Oh, typo on the website?
Yeah, the dash should need not be there. This here. I'll just scroll down. Yeah. But it should show you the version. Once it finishes installing, it should show you the version.
So, at least on mine, I had to apt install unzip. Did you use unzip in the next step?
Yes, but I had included that as a dependency, but okay. Yeah, let me do that then. Yeah, I have it. Anyway, is everyone missing unzip here? Okay.
I want a CD back. I was in Sweden when I ran that, so I want a CD back.
No, that doesn't matter.
I just kind of copy and pasted that, but I also already have this downloaded.
Yeah, it looks like some of you don't have that downloaded. In that case, just do sudo apt-get install unzip. What I'm gonna do is
The unzip function.
no, that's a package.
Yeah, I already have that. But
Previously.
yeah, good.
And you do need to run the next commands from backslash or from tilde slash, not from swig.
Just
So
a
they can
second.
swig from the previous command.
Oh no, that should be fine. You give the absolute paths. So for what? For which step?
Yep, that one.
The core network.
This one.
That doesn't work if you're in the swig directory.
Oh yeah.
You need the CD dot or CD tilde slash.
Okay.
Whatever you do run.
Let me try that.
But if you run the commands, there's a non-absolute path in there. Or at least when I ran the commands in my terminal, yeah. Then after CD dot. And it looks, there's probably just one place where it's not an absolute path or whatever.
Yeah. Let me just copy paste it. If it works,
But if you want to copy paste it, yeah, as long as you're in that directory, it's fine. But if you're in swig, it doesn't work. So what are the main differences? Why would I want to use
yes, we'll get to that. Yeah, I'll talk about it. Yeah, I just don't want to, I just want to get on with the installation process. That takes some time. So when that is installing, I'll talk about, well, what's the difference between OAIC and FlexRIC. Sorry? Sorry? Yeah. Yeah, I think that's what he was mentioning, right? You need to.
Yeah, CD tilde slash, you didn't do the unzip. Oh, so the unzip assumes you're in tilde slash.
Yeah, so it basically extracts the files in that folder. So if you go out after that, it won't find it. Yeah.
So you have some other projects running?
So I still have a bunch of Kubernetes stuff running.
That's okay.
I do a ps-a, I get like time.
Yeah.
Process. How do I kill off all the provisions?
No, you can undeploy it, but I don't know if you're going to use it for tomorrow's demo. So that's why I didn't mess with it. Usually it comes up on the first few lines, your OAI core network.
Okay, yeah, I see. the-
Yeah.
OAI.
Yeah, they'll all be, yeah, I'll come to that. Yeah, I think,
So anyone else having any problem? Please raise your hand if you cannot move forward. If the command is not working, please raise your hand.
so has everyone completed Docker pull? Okay. Yeah, let me wait for mine too. I think everyone's ahead of me this time.
So my version of Docker has a few more things. So when I go to deploy the core network, but again, I think I have a different version of the. So when I go to, it just includes like the UPF and stuff too, which I don't think.
No, it's there.
Oh, is it?
Yeah, yeah, yeah.
Oh, I'm in the wrong thing. Sorry.
If you see here, it will be listed. There should be 10 containers. Maybe one of them is.
Yeah. Okay. Yeah, you're right.
Maybe the picture has one cut off or something. I had resized it. Sorry.
It says you have 11. It's supposed to be 11.
No, 10 is fine.
Okay.
I've written it in the documentation. Yeah.
All right. Yeah.
No, that there were other parts as well. So that was. Yeah, so we'll just deploy the core network. Does everyone have this up and running? Anyone facing any issues? Okay. You can list the containers and see, yeah, which of them are running here. You'll get a huge list because you've been working with them since yesterday. So you need to wait till all of them are healthy, and all of them will be named as OAI Software Alliance and OAI. So
The new ones appear first.
yeah, usually, yeah.
So how many should we expect?
10.
10.
Yeah.
So please check if you have those 10, what do you call, processes?
Containers.
Content, 10 content. Yeah, all 10 content. Healthy.
Is it all version 2.0.1?
Huh?
Version.
Yeah, I'm getting. I'm just seeing like some extra information. I just want to make sure it's all. Oh, you're in a different branch. Oh yeah, because I'm version 2.0.1 and you're in the develop branch, right?
Yeah, the develop is like the latest. I think you're using the old ones that you have.
Okay,
Yeah.
Okay.
It should be fine. Don't worry about it. Yeah, let's just turn the core network off for now, or you could leave it. Doesn't make a difference, but just to show you how to turn it off. Yeah, you do sudo docker compose down and it brings the core network down.
So you can activate quickly anytime because it is installed.
Yes.
What is good?
Yeah, it won't take this much time. So if you do sudo docker compose up, up is for getting it up. So then at that time it just starts because you already have downloaded the images. Yeah, we'll we'll download the OAI open air interface repository and build it. So while it's building, we'll talk a little bit about FlexRIC. Is everyone okay till this step? Yeah, the path is fine. Yeah.
Quickly, the command you've got highlighted,
Yeah.
where should I run that from? What path? When I do the git clone?
It doesn't matter. So
So it's okay to clone inside OAI?
yeah, it redirects to the home directory. Anyone facing any issues? Okay. Yeah. It's not a very huge file, but yeah.
You know, while we got a minute, can you tell us, do you have a minute to talk about FlexRIC? While it's cloning?
Yeah, let me do that. Yeah, okay. I guess everyone's ahead of me, so I shouldn't wait till I have come to that
We're
step.
just all sitting here waiting.
Yeah. Yeah, I had already talked about the near real-time RIC and the ORAN ecosystem yesterday, right? Yeah. So FlexRIC follows a software framework, an API sort of framework, an SDK framework, which is quite in contrast to what the OAIC rig does, right? They have a modularized structure and a very customizable framework. The modules in FlexRIC, so there are a couple of modules here which are very similar to what you see in the OSC's near real-time RIC. You have a subscription framework, but and an E2 agent. But all of these are programs, C programs running on bare metal or a VM or you could Dockerize it, but there is no modularity or separation between any of these components. So basically the E2 agent, if it receives a message, it's going to call an API from the subscription agent so that it can communicate. So the communication is much quicker here since it's just a C function call that's happening. But in Docker, you would have seen that whenever you want to communicate something to another entity, you would have to use your service endpoints. That doesn't happen here. There are no IP addresses assigned to each of these components. And here, yeah, FlexRIC has support, E2 agent support for both the LTE and NR versions. We will be using the NR version with the GNB. And yeah, the XApp SDK. So there are two different, you can separate the supporting SDK from the actual XApp SDK. That is pretty well managed within FlexRIC. So all the E2 communication that you need to do, there are specific functions, and there is pretty good documentation on how you need to call those functions. That reduces a lot of overhead in the sense that you don't have to learn about all the cloud native stuff that you need to go through if you're employing the OSC's near real-time RIC. But again, this doesn't perform very well if you want to scale it up. Like if you want like 100 or 200 instances of an X app, it's going to be a bit tedious to manage it. But with the OSC's framework, it's going to be easier because you're using Kubernetes. You just need to tell Kubernetes to deploy 100 of them, and it will do it, and it will manage it. Assign the amount of resources, or based on priority, you can do resource management. But here it's a bit limited. So there are advantages and disadvantages to both of them. So that's why in this workshop we are offering both, and you're installing and using both. So whatever suits your use case, you can go ahead with that. Let me just, yeah, build this. This is going to take some time. So
So if you have to
yeah,
tell us one reason
yeah.
why we should use FlexRIC, what is the main benefit?
If you want to get something up quick, uh, let's say you have an idea for an X app, uh, and you can have a standard compliance system with this as well. But if you want an easy way to test out your idea or hypothesis, this would be much easier to handle, unless you are very proficient in Docker, Kubernetes, and stuff like that, right?
So basically, it is much simpler to use for research compared to
Yeah,
OAIC.
yeah,
Is that
yeah,
correct?
yeah. So all you need to do is, so let's say you have an idea for a traffic steering algorithm. You would have come up with some sort of framework for the algorithm, right? And anyway, you will be coding the algorithm. So once you do that, the overhead here is communicating the decisions to the RAN or getting reports from the RAN. So that is pretty easy in this. Because for a new person who is getting introduced to this, it's easier to track as to what is happening at each place, right? Uh, but you saw that OAIC has like 14, 15 components, and you don't know what's happening where and what's going wrong. If something breaks, right, you don't know what's breaking, and it will take you some time to figure it out. That way, this is much better. It will help you get on the road faster.
Just to follow on, so basically
Yeah.
I can take like the X app that was demonstrated this morning and yesterday, and I can make you dedicate the same way, or do I need to do something?
No, okay. There are a couple of caveats here. If it's a standard compliant XApp, right, you could deploy it. One thing to note here is that, let's say you developed a traffic steering.
What we showed this morning.
Yeah, let's take that example. No, that was not a standard compliant. What Josh showed yesterday or something like that. KPM XApp, for example. That was basically collecting metrics, right? That was developed for OSC RIC, and now we want to deploy it here. Let's say now you can't deploy it in a cloud native format because this follows an SDK format, right? So let's say you got the code, you extracted the code, and you deployed it. I wouldn't guarantee that it would work with the OAI RAN because the RAN needs to support those functionalities. That is the caveat here, right? When you're working across these multidisciplinary systems, you need to be aware of what supports the functionalities that each framework offers. Uh, yeah, there are differences in that. What SRS RAN supports some functionalities, OAI supports some functionalities, and it works the other way around too, right? FlexRIC can expose scheduling modification, for example, but SRS RAN might not expose that. So even if your XApp has that functionality, it might not be supported. But that's because it's the early stages, right? Both
if
of
you want to develop some Excel,
yeah.
it can use either OAIC or FlexRIC.
No,
No.
no. The interfaces are standardized, but the XApp SDKs, they are not standardized. So the API calls might be different. So you need to still translate that. That is there. If you have a XApp, the messages that the XApp exchanges with the RAN, that is standardized, but the way it's implemented, that's not yet standardized. But and that is something FlexRIC is trying to do with their subscription messages. So only the communication between the XApp and the subscription manager, if that is standardized, then it becomes independent of the implementation. So that is something they're trying to do, but again, it's a difficult process, right? Trying to get everyone to agree on a single thing, it's challenging. Yeah, we'll be going through one of those today. Yeah, we'll be doing that. So we will, yeah, since it's still going on, we'll be executing the KPI mon XApp, see some metrics, and then yeah, and then we will try to and then we will try to code the RAN control XApp.
Yeah, basically, if you want to do some iterations, make some modification, try
Yeah.
something, again make some other change, and this will be much easier. That will be much easier to do in FlexRIC.
Yeah.
But once you have finalized your Excel, then eventually it will be a good idea to use the OAIC.
Yeah,
because
especially if
this
it's
cannot be so-called published directly.
yeah, especially if it's going to be used by a lot of people, right? This doesn't scale well. With a Dockerized deployment, you can come up with the application, package it, or include all the dependencies, host it as a image, Docker image, and a lot of people can just pull the image and deploy it if you want to make it open source. But let's say you're in an industry sort of environment, uh, people will be requiring multiple instances of the XApp, right? Especially if it's a very big deployment and covering a large area. So at that time, again, this OAIC RIC kind of framework helps for industry. It's more focused toward. That's why they employed that.
Deployment. But
That
if
is,
you are
yeah.
doing testing, then I'm a small company.
Yeah.
It's a small company.
Yeah.
Right? Then he wants to try this, try that, right? So if somebody wants to do something quickly,
Yes.
then FlexRIC will be
Is better. Yeah.
If you want to deploy it commercially across the US or big states,
Yeah.
then OAIC would be better.
Yeah, or you want to perform a stress test. Let's say I have an XApp and a system. If I keep deploying multiple versions of the XApp, how much can the system take, and what is the resource usage, stuff like that. Yeah. Yeah, you might see some warnings. That's fine, but you should get the build should be successful message. Okay. You can switch back to yeah.
Just to summarize, try to summarize. If you want to build an XApp, say,
Yeah.
open source RAN,
Yeah.
you need to know the RAN too, right?
Yes.
And make modifications to the RAN.
Yes.
So if you want to develop an XApp for a software-based RAN, open source software-based RAN, either OAI or FRS, you need to know how the RAN functions and make modifications to the RAN itself. So the XApp can provide useful information to the RAN or receive useful information from the
Yeah, people usually assume that, since the focus is mostly on XApps and people keep talking about XApps, okay, they think, okay, let's come up with an AI algorithm that, make some decisions, let's say a handover decision or something like that, right? And that work on developing the XApp itself. But then at the end of the day, the XApp has to interact with the RAN and has to get data from the RAN, feedback from the RAN for it to make decisions. That is something which is not like readily available. People, yeah, development is happening, but it's slow, right? Things take time to you need to make sure that you are putting out the right stuff. So yeah, you need to know about both the RAN side and the RIC side. Yeah. Oh yeah. Yes. OAC deployment with OAI as the RAN, right? But I don't understand. OAC deployment with yes, yeah. That yes. I didn't cover that. Let me go back to my presentation. Yeah. So. Okay, I don't. I'll just give you an overview of that. Yeah. Oh, yeah. So there is something called IAP within FlexRIC. So that's the layer which functions interacts with the XApps, right, and exchanges the message. Now, this is something that they have developed, which is like pretty fast, and they have their own communications protocol for that. They call it the E42 interface. So they want to kind of standardize this so that independent of the XApp framework, you can have communication with any type of RAN or RIC. Basically, SDK standardization loosely translates to SDK standardization.
So is there yet another group working on this one?
Okay, so OAI is offered by Mosaic 5G. URCOM. They have another group called Mosaic 5G. So it all comes under the same master organization, parent organization.
Yeah, so it's separate. Separate from OSC, ORAN.
Yeah, separate from OSC. Yeah. I mean, anyone can contribute to it. It's open source. They do have developers from other universities also contributing to it, but mostly it's URCOM. They're the ones who are doing it. Okay. Sorry?
Error, yes.
Oh, okay.
Yeah, okay.
I'm sorry. What was the Docker code to check? What was the typo here? Was just no dashes?
Yeah, no dashes.
Okay.
Or you have to do -B.
Just -B.
Yeah, one of those. Okay. Or just do it without the dashes. Gotcha. Simpler.
Yeah, I'm just trying to do this on my.
Okay. Yeah, let's set up FlexRIC quickly. This shouldn't take much time.
Is it just Docker version or different things for all?
Oh yeah, Docker version is different.
Yeah.
Docker Compose version.
Is it -compose or?
No,
Okay.
space compose. There is a -compose version as well, but we have done space.
Docker Compose is not a command.
Did you install it again?
I did.
Let's try hyphen then. Maybe this is 20.04, right?
This is, yeah, on the VM.
I think it's not installed.
It said it's installed.
No.
What?
Did you just copy paste the whole thing?
Yeah.
No. Do it one by one.
Okay, I got you.
Yeah. Yeah, make sure that you see this in your CMake output. You need to have Swig and Python 3. And yeah, so this basically denotes the encoding that is followed by the service models. You should see ASN encoding for the RC and KPM service models.
Anyone else not getting the swig? I'm not seeing swig on mine. Well, it's a swig.
Yeah. So let's see. Yeah. So Swig should be after the encoding. You don't see that? No, sometimes it executes in a parallel fashion, so it can get mixed up.
So here's my encodings. I'm seeing, SSL blast webpack, but I don't see you mention a swig. Will it tell me it failed?
No, it has. Wait, what is this? Is this FlexRIC or is this?
Oh wait, I may be in a different step.
Yeah, yeah, yeah.
Okay, this is
This is OAI installation.
Oh, okay. So I should be.
You're fine.
Okay.
Yeah, the FlexRIC comes next.
Okay.
Yeah.
I'm off my step.
No.
So I just-
Sorry. Yeah, it's here.
Oh, it's there. Okay.
Yeah. No problem. Yeah, once you install FlexRIC, you should see the shared objects being written to this path. So yeah, is anyone stuck, or is everyone with me here? Okay, yeah, we'll wait for you. And by show of hands.
Other than Dimitri, anyone else is behind? Do you want us to help you? Please raise your hand. Unless you kick and scream, we will assume you are doing fine.
The what?
So when check out the git state.
Oh. Yeah, that is fine. That's okay. Yeah, that's because we're checking out a commit. It says that it's okay. Do you need any help?
No, I'm good. I just realized that for my own thing, the Qt5 thing is kind of getting in my way, but this is working on.
Okay.
So I'm trying to get ahead a little bit. -D is giving me an error. I just did sudo docker compose up and it's fine. But if I do -D, then it's not fine. Here, I'll just shut it down. Wait, but all this.
Yeah.
I think that's just a typo, right? So if I do that.
Okay, it's a formatting issue. It's supposed to be no.
Okay.
I think the font there's a
there's some font thing in
yeah.
here. Okay.
So your terminal is I think
because I
translating it.
I copy it directly.
Okay. So you did. Are you running this on Windows?
No.
or
this is
SSHing from Windows.
SSH from Windows.
So Windows translates this differently. The hyphens.
Oh, the
That's
hyphen
the problem.
is the wrong
Yeah.
character. Oh, but I think it's the wrong character here.
No,
No?
I don't think so, because this is bash, right? So all of them are processed in the same way. I did an RST file, so all of them are.
Look, see, that's the wrong dash. That's a long dash, not a. That's a Unicode dash, not a.
Yeah,
not
it's the,
that.
yeah,
That's what you want.
yeah.
So you put it's the wrong in the RST file.
Okay, let me check that.
And if you want, I can send you a pull request. I've been trying to keep up with this.
Okay, that should be fine.
But that's what it is. It's the wrong dash.
Yeah.
It's the long dash.
Yeah. Okay, so let's start the 5G core network.
So for you may want to answer, I think everyone will have that problem.
Yeah.
You have not reached that stage.
Yeah, I have not reached. That's why
Yeah.
I'm.
So there is some kind of typo in a character, but Pratik will let you know. There is some dash problem, so he will let you know. Okay. So Pratik, looks like people are moving faster.
Yeah.
So you need to catch up with them.
I just like to stay here.
Stay okay.
Running the problems.
Okay, so this is the problem. The dash.
Yeah. So it says
Yeah.
no such service.
Uh-huh.
I think it's a formatting issue. So delete the dash. Yeah, backspace and retype the dash.
Oh, do backspace,
Remove and put it
dash.
back.
Okay.
Yeah.
Yeah. So remove the existing dash and add your own
Yeah.
dash. Okay. Okay, then we should be good.
Let's just check if everything's running. So you should have all the 10 containers up. The name of the core network. So basically, the network functions in the core network, right? This is using OAI solution for the core network. What you see here are different network functions. So you have UPF, SMF, AMF, all of that are deployed in a modularized format. So they are quite independent of each other. And all of them, we got them from Open Software Alliance. So that's why it's named as such.
So it is OAI core network.
Yeah.
5G. Yeah,
Yeah.
so it is OAI 5G core network.
Yeah. Just delete it and retype it.
Would it be nice for like other people to put notes in there?
Yeah. 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 We are going to fix
We
it.
will have to update the website.
Yeah. We'll update the website.
Yeah, we found 2 or 3 areas.
Yeah.
Oh, good.
Yeah.
Very
Thanks.
good dash.
Yeah.
Remove that dash and good.
That doesn't take too much from the good work they did.
Oh yeah, yeah. So you get only partial credit.
Oh, I get no credit.
No. You will get some credit.
We'll put it against your commit, against your pull request. Yeah.
Yeah, thank you for contributing to the open source.
Yeah, before I run the GNB, let's just have a couple of terminals ready. So for now, we'll be needing about four terminals. Yeah. Is everyone with me here?
Do you do that in the
Yeah, you can do that in the same terminal. So we'll first start the GNB, and in a new terminal we'll start the UE. And in another fresh terminal, we'll start the near real-time RIC. Yeah. Yeah. Once we deploy FlexRIC, that will be fixed. Oh, yeah, let me talk about that. So when you bring the GNB up, you might see this message that E2 setup request has timed out. Because when the GNB comes up, right, it keeps sending a E2 setup request to the near real-time RIC till it gets a response in this particular program. Usually it's the FlexRIC which is brought up first and then the GNB, but just for you to see this, I just instantiated it in the beginning. But yeah, it should not hamper your progress. So let's get the UE up. Yeah, here there's a lot of data that's being exchanged with the GNB by the UE, basically RACH, random access messages, and trying to get an IP by establishing a PDU session. You can, yeah, you can see that the PDU session is being established here. It's sending a PDU session request, and yeah, there's a session established with this particular IP, 10.0.0.2. So you need to get an IP. Just make sure you have an IP at your UE side. And yeah, the RSRP doesn't change because it's a simulated UE. Yeah, but once we get FlexRIC up, yeah, that's okay. Yeah, once you get FlexRIC up, it should say that it has received the E2 transmission from the near real-time RIC. So it says that here E2 setup request received, and this is the node ID, the E2 node, which is the GNB ID, and it's saying it's of GNB type. So there are different types. If you are employing a split architecture, like a CUDU kind of architecture, then it will say a CUDU split and what entity is actually getting registered in the near real-time RIC. These are basically indicating what RAN functions are offered by are exposed by the RAN, and since the E2 since the near real-time RIC is also configured to accept those RAN functions, it is accepting all these functions. One thing to note here is that the E2 SM KPM and E2 SM RC, these are the standardized service models. All the other ones are basically customized service models, meaning that they are not according to any standard. That it's basically an encoding scheme that OAI themselves came up with for a couple of different other applications or different XApps. So yeah, once you have that, yeah, you can exchange downlink or uplink traffic. So for uplink, you just do ping and yeah. So this is the IP address of the entity within the core network. It's basically a traffic generator, and it's been assigned this particular IP. And then this is your UE interface. This is the interface which has the UE IP. So basically what you're saying is ping this particular guy through this interface. So the data is transmitted through the UE and not through some and the 5G networks and not through some Wi-Fi or something like that. So yeah, I just want to stop here for a little bit and just want to check if everyone is on board here with me. Anyone lagging behind, need some assistance, or any questions?
Terminal 2. You display the power there. What's that? My something dBm.
That's the reference signal received power of the signal that is coming of the signal that the UE is receiving from the GNB. Yeah, the GNB also records multiple metrics. So basically, here you see UE ID and what's the again signal strength, RSRP again, the blur. Here it's all 0 because it's a simulated UE. You don't have a radio, right? But yeah, and and it's pretty stable because it's a simulated UE. And the number of PRBs and stuff like that, SNR, and then MCS. So here it's using 9. That's the default. So you can there's a maximum MCS maximum is 28. You can configure it to change or not depending on your network configuration. Let me just stop this for a second. Yeah, any other questions, or is everyone? Yeah. Yeah. Okay. Why is your UE still running? Okay. Open a new terminal on any new terminal and just type in ifconfig. Yeah, you'll get some virtual adapters as well, but scroll up a little bit. Just give me a sec. I'll get my UE up. Yeah, you should see this OAI TUN UE1. And this is the IP address of that.
Can we make sure your Zoom is muted?
I'm not joined audio.
You didn't join it?
Yeah. Yeah, before we move forward, a quick aside. Yeah, let me use this whole thing. So when we brought the GNB up, yeah, when we brought the GNB up, you saw, yeah, when we brought the GNB up, you saw this command, right? So in our soft modem is the GNB program, the main program which instantiates a GNB. And you see that we are giving the path to a configuration file. So this is the configuration file that we use. And we are giving some other parameters to operate in standalone mode and in simulated mode. A quick look at the config file, just to give a flavor of what's going on there. You can open it if you want, otherwise it's fine. Yeah. So there are many parameters that you can configure here. I'll just bring your attention to a couple of them. And you'll have to be a bit careful about meddling with these because they're quite interdependent and you'll need to change a host of parameters. Let's say you want to get to a different frequency or something like that. You'll need to make some changes because they have many options here and they can change based on, let's say, the frequency that you choose or the subcarrier spacing that you choose and stuff like that. So we have the number of the bandwidth that you can allocate, for example, and the subcarrier spacing, the band at which you want to operate. So 78 is TDD band. So yeah, and they have support for various configurations, FDD, TDD, and different bands as well, band 3, band 78, 41, and yeah, many more, 70, 77 and stuff like that. So yeah, if you are interested in, and you can give a propagation model as well, so that uh, you just don't see some sort of constant response or constant signal response for a particular simulated UV. So there are options or customizability options to do that as well. Yeah.
Sorry, why do you need to set up the frequency again?
Why do I need
Why
to
do you
set?
need to set up the frequency?
No, if you want to operate at a different frequency, you need to change some parameters.
That is if you're using USRP.
Yeah, if you're using a USRP, basically. Yeah, if you're using a real radio and yeah. It has support for a channel emulator. Yeah, with some propagation models. We don't use it, not in this demo. But yeah, we could. We'll see if we have some time left. Maybe we can explore that. Yeah, it's equivalent to ZMQ, but OAI had developed their own libraries to facilitate that. Basically, it's called an RF simulator. SRSTAN uses the 0MQ library, but they came up with their own implementation of that.
Excuse my stupid question there. So you said it has the RF emulator?
Yeah.
And it works with hardware, or it just works only with one?
No. Yeah, of that I'm not sure whether it works with hardware as well.
So right now they support inherently
Yeah.
some simulation of the radio channel.
But this saying is using USRP now.
No, not now.
Not in this one.
Here
Everything is
Yeah.
software.
Yeah.
Yeah.
Sorry.
In the morning or in yesterday, when we were using that SRSRN or some other software, so that works with another simulator called 0MQ. Okay, so there is one kind of way of modeling the radio environment, radio channel. Here, they, as Pratik mentioned, this FlexRIC kind of package has its own radio simulator called RF simulator.
But he's saying that right now that configuration file is configured to use USRP.
No.
No, just the RF parameters.
Neither nor. It's not using the simulator and it's not using the
Yeah.
What are you using?
No, I'm using the RF simulator, but I'm not without. With an ideal channel. Yeah.
Yeah, it's a perfect channel.
Perfect channel.
Perfect
Yeah.
channel.
That's why you can add this module, the emulator.
Yeah. Basically, whatever IQ samples are generated at the UE, it's just piped over to the GNB.
It's like a wire line.
It's a wire line. Yeah.
Sorry, it's late during the day,
Yeah. Yeah. Okay. Okay.
Oh,
Yeah. So when I'm instantiating the GNB, right?
So without the flag, if you have like the UHD,
Yeah.
for example, front hall, then you can use the same configuration.
Yeah. So I have set a flag here saying RF sim. So that's why it's acting as a simulator even with the USRP configuration file. But if I don't set that, then I'll have to connect USRP. Yeah, we can move on to the XApps, running the XApps. Yeah, we will first run the KPI mon xapp. Yeah, let's see how that goes, and then we'll immediately move on to implementing the RAN control. Yeah. Oh yeah, I didn't talk about that. Okay. In all of these commands where you need to generate traffic, I have said UEIP. So that you need to figure out by, let's say, using ifconfig. I think I've written that somewhere. Yeah, find out the IP address by running ifconfig. So that's the command to.
So Pratik, in this overall procedure, which step you are at?
I am at.
Streaming with
Yeah.
that one, right?
Yes.
So you didn't, you have not reached that stage.
No, I was going
Right?
to.
Yeah, okay, good. Then we are good. Yeah.
So yeah, we did this. Let's just stream some traffic with iperf so that I show that how it's done and nobody has any other doubts. Yeah, let's get the GNB up. Yeah, so in one terminal, you can bring up the iperf server. Yeah, here it's asking you for an argument, like asking you for the UEIP. Do ifconfig, just run ifconfig, and you need to scroll up a little bit to find the OAI TUN UE1 interface. So that will have the IP address of the UE. Yeah. No, all of us have independent 5G networks. And it's programmed to assign IPs in that order, 10.0.0.1, 2, 3, 4, 5, like that. Yeah. Yeah, so all of you will have a similar.
Does anyone else need help?
Oh, this is not up. What is this? This is UE. It's not connected.
Please raise your hand.
What is
if you
this?
need some help.
Okay, different.
So you are.
This is RIC. Okay, this is G node B. Okay, this is running. Let's.
Yeah. So then.
Oh.
Control. That one. I see.
Okay.
OAI TUN underscore UE1. You see. No, it is highlighted on the right hand side. OAI. You see that highlighted the right. So look for OAI TUN. Yeah. So most likely it is that. Why don't you check?
Yeah, you're right.
You got it? You're the same one? Good.
How do I go there?
Today is your lucky day. You got the same.
Yes, it should make this training a whole week.
Are we?
It's not very, very good information.
Oh. Now, what is this for? Okay. Yeah. Execute the UE here and it should work. Yeah, so this is basically a Docker container, a traffic generator that OAI has built in with the core network. So you can use that to simulate downlink traffic. So you have a server at the UE side and a client trying to transmit data, which is at the core network. So that's equivalent to a downlink scenario. Okay, so before I go any further, any questions? And is everyone done with this? Okay. Yeah, I'll wait for you. That's okay.
It's just my computer. Everything else seems to be working.
And just
fine.
to Control C.
Yeah. So wait. So you said. But so running.
Yeah.
Okay, gotcha. Where are we? So we're.
Yes, we completed that. Oh, you have T marks.
Yeah.
So yeah, next we'll run the KPI-mon XApp, try to, so we'll have this setup, the GNB UE connected to it and transmitting some traffic, and we'll see what kind of metrics the KPI-mon XApp collects from the RAN. And in the next step, we will code a control request and transmit it to the RAN from the near real-time RIC and try to release a particular UE which is connected to the network. So yeah, let's, yeah, a little bit about the KPI-mon XApp. So it's basically using a service model that's been defined by the ORAN Alliance. They provide specifications. If we have time, we will go over some of the specifications and see how they're actually implementing it. But yeah, in the interest of time, let's just do this because for RC anyway, we'll be going into some of those aspects. But yeah, let's see some metrics here. So I'll bring my GNB back up, my UE. FlexRIC and some traffic. So yeah, sometimes the IP address might change. So I have got .3 now. So if you get an error when you execute with .0.2 saying the bind failed and cannot assign requested address, it's most probably because you have been assigned a different IP. So just check for that and then update that in your command. So here basically I'm transmitting data at 10 Mbps data rate. Now while this is going on, let's open a new terminal.
Not you, sorry, my thing froze again.
Oh,
I was on a roll.
and yeah, let's execute the KPM on XF. Yeah, so you should be seeing some metrics here. So these are collected over a period of time and aggregated. So some of the metrics are aggregated. So you have the throughput in downlink throughput, uplink throughput, and the number of PRBs that have been assigned for downlink, uplink, and so on. So since we are transmitting traffic in the downlink direction, you see that the PRB usage is also pretty high there. As compared to the uplink where only control messaging is going on. And again, there are other metrics as well. The UEID. So we will use this UEID to issue a control request to the RAN to release this particular UE from transmitting data. So yeah, let's do that. And then if we have time, we can come back and explore some more of this. So we have, okay, we have 1 hour 45 minutes. Okay, should be enough. That's a limitation. It's that's something that we have coded in this thing. It's a hard-coded value. You can just say sleep or wait, right? You can just say wait for an interrupt, and it will keep going on. Yeah. So all of this is being logged in a file, in a text file kind of format, within the system. So before you know it, all of it kind of blows up in size, and you won't be having any space left in your system. So that's why they limit it. And it's usually good to, unless you are working on something, it's better to limit it. Yeah. So was everyone able to see that on your machines? Okay.
The big advantage you're seeing is just agility, that it's faster and easier, so you don't have to deal with all the containers, you can just modify the code, compile, run, it's a little bit easier to try to experiment.
Yeah.
So for experimentation research, then you want to try different things quickly, this works very well.
Because you saw that, just installing it and deploying it was quite easy, right? No, none of the Kubernetes things that you had to get, install, and figuring it out. Yeah. No, that's okay. It's aggregating the numbers. So it's collecting it over a period of time and aggregating it. Like, yeah.
Yeah, instance I'm going to reject the buffer.
Oh yeah, and yeah, that might be happening. It might be overflowing the buffer, and there might be a memory leak or something. Once few iterations have passed. And it's in microseconds. So let's see. Yeah, that's a pretty big number. I think it's a, yeah.
There might be some error.
There might be some issue with that. Yeah. But I think the other aspects look fine. So it's okay.
So just to kind of follow up on this question.
Yeah.
So this is the same thing as what we did yesterday. The
Yeah,
You don't have to worry about today.
Correct.
yeah,
Correct.
exactly.
Correct.
Yeah.
Yeah. There are different options like buffet menu, right? So you pick this, you pick that. Yeah. Yes. Much simpler.
Okay.
So we are moving to a new topic.
Yes. So we'll go to the RC XApp. Code a control message to we'll modify some of the XApp parameters, and then we will make some modifications at the RAN as well. Build it, so you'll have to rebuild it. Once you make some modifications, you have to rebuild the whole thing to see so that the compiler knows the modifications, right? And then we will see how our modification is affecting the RAN. So this is a very simple example. So we'll be basically telling, so we'll have this kind of scenario where there's a GNB and a UE connected to the GNB with some traffic, or even if there's no traffic, that's fine. And we will tell the XApp, we will code a control message at the XApp to release that particular UE that's connected to the GNB from the network. And we will see if that is getting executed or not.
But ideally, we were supposed to have a break at 4 o'clock.
Yeah, we
Okay,
can. Yeah, that's
so
fine.
we can do 7 minute break.
Sure,
7 break,
sure.
right?
I think we
Before
have
start
time.
this.
Yeah.
Yeah, because once we have steps, we should not.
Yeah,
keep it,
yeah,
right?
yeah.
Okay. So let's have a 7 minute break. So 4:29.
Yeah.
Yeah, 007. 007.
Yeah, I think Josh is handling all. He'll fix it. He's the one with administrative access. So, yeah.
Everything I put notes on is.
Thanks. Thanks a lot.
Do you need a short break or can I ask a question?
Sure.
Okay. So I looked at the RF simulator
Yeah.
and I looked at the code and it generates a random value. So I don't understand what. Okay, they have two simulators, by the way.
Oh,
They
really?
have the RF simulator
Yeah.
and then they have an E2 node agent simulator.
Ah, yeah, that is different. Yeah.
But how is the RF simulator?
No, the
Are you
E2
using
node
it for
agent. Oh, that.
that it generates a random value.
So which generates RF sim or E2 node agent?
I think I'm thinking of the E2 node agent.
Yeah, the E2 node agent is like a stand-in simulator. It's not of. So
Because
that's
let me
basically
tell you what I wanted. Oh yeah,
no
please.
problem. Yeah.
What I wanted is okay. I have these papers with slicing, so I want to abstract it to a simulation so I could do some more optimization instead of relying on the crashy SRS that I was relying on.
Yeah.
So I went to the E2 node agent and I said, okay,
Oh, that doesn't
because
work.
their slice only works with their
Ah.
KPM version and everything only works
Yeah.
with the E2 node agent.
I know that was a hack they came up with to kind of just show the slicing functionality.
Yeah.
Basically, if you what it boils down to is that whatever values that you're writing, right, that's being reflected in the E2 node agent
Yeah.
program.
And they generate a random value.
Yeah.
Yeah.
But there is another branch called RC slice, RC underscore slice. I think that has like slicing built into the RAN, the OAI RAN.
Oh.
So this E2 agent simulator that you were talking about, that's not at all part of OAI RAN.
Okay.
That's a separate entity that they came up with just for testing this XApp thing.
Sure.
If you want a quick test of the XApp, whether it's compiling properly and whether it's sending the values that you want, right? And you don't want to do the RAN coding part. Otherwise, you can't decode the XApp, right? So you just use the same libraries to decode it and see if it's transmitting
No, I
properly.
get that. So the RF simulator is robust, right? What do you think?
It's pretty robust, yeah. And you don't need to use that GNU radio, right? If you
Yeah.
want multiple UEs.
Oh, okay.
Yeah, it's all you have to do is just change the IMSI value, IMSI value, and if it's there in the AMF's database, it should be fine.
And you're saying there's a branch that they've done the slice aware scheduler in of the
Yeah.
RF simulator or the real RAN or the real GNB?
The real GNB
It's 5G?
and RF simulator. That's applicable for RF simulator as
Oh.
well.
So I don't understand what the difference is.
Go ahead.
Yeah, no, go ahead. Yeah. I don't understand what the difference between the RF simulator and the GNB is, other than there's a virtualized channel here.
That's it. There's no other difference.
But you see, to me, when you say GNV and UD on the other side,
Yeah,
I see that there is a channel between them and air.
that is,
So
yeah.
when you say emulator, I understand that you don't have the air in between.
Yeah.
That's what
Yes.
I'm confused.
Yeah, other than the actual channel being different, the functionality of the GNB and UE is the same, meaning that they implement the same code, the same LDPC algorithms and stuff like that. Channel estimation algorithms, all of that is the same.
But their splicing only works with 4G right now, right? I think so.
On their main branch, it's
Yeah.
only with 4G.
I think
Yeah.
so.
Yes.
Because their service model is incompatible.
Yes.
Right, I think so.
Their service model is compatible.
Oh, they don't have a scheduler.
Yeah. They haven't modified the scheduler to reflect the values that you write into your control message.
Gotcha.
Yeah.
As you know, the OAI community, unless you like ask them a very specific question on their mailing list or something, or you just know somebody,
Yeah.
you basically have to figure it out by yourself, actually.
Yeah.
So that's what. So just to be sure. So what you showed yesterday, excellent. And what you showed today,
Yeah.
they're basically the same function, except what he has is a little bit more.
Yeah.
What's the difference between what he did yesterday and what you did today?
It's a bit more
Other than
feature
he
rich.
use computerized, containers.
Yeah, it's a bit more for the industry, right? So what their aim is, the ORAN software community, right? So ORAN Alliance comes up with specifications, like saying, okay, this should be the format of the E2 message and stuff like that. What these people do is implement that as a reference for other companies. So this ORAN software community is formed as an alliance of different companies.
But
Nokia,
for us, like we have a specific application.
yeah,
Because we don't have a lot of, we don't need a lot of complexity. We can just
Yeah,
use,
exactly.
We don't have slices,
FlexRIC's the
we don't
way
have
to go.
anything.
Yeah.
exactly. Yeah, it's more simple,
Yeah,
right?
exactly.
Yeah,
But the other thing is, so if you were to use, if you were, sorry, Josh.
No, please, no.
No, I don't need to.
This is
I
beneficial
really
to me.
enjoy talking to you
Yeah.
guys. I'm
Yeah.
glad I came.
Yeah.
Really nice. So let's say if you want to add the radio in between, so you have the UE and the radio in between. So you just get in the configuration file, you say use
Yeah.
whatever.
yeah.
And
You
then
just
what
need
do
to connect.
What do you need to do to get the radio, the USRP radio? Do you need
Nothing. You don't need to program it. They have built in the functionality there. So you just need to connect your, let's say you have a B210. Yeah, if you have a B210, just connect the B210 and don't give that RF flag, RF SIM flag that I gave.
And then on the other side, you have to have a UE, especially if
You can have a smartphone UE. So that B210, let's say you have a GNB B210,
yeah.
that's basically broadcasting signals, right? The PVCH signals and stuff like that, broadcast signals, so that the UE can decode it and
And
register.
then the UE, do you need to give it a special SIM?
Yeah, if you are using a phone, then you have to.
Yes, in our
Yeah.
case, we want to set up our own private network.
Yes, if you.
What we really want to do in a dedicated is we have the UE and the G not be there, and we want to come in and introduce our jamming.
Yeah, if you are using, let's say, a B210, right?
Yeah, I think we have, I forgot B210, B200.
That's the UE. Yeah,
But
B200,
right now we have the
B210
G not be, but the UE I would like to use
phone, cell phone.
cell.
Yeah, for that you'll need a SIM card. It isn't difficult.
It's so easy to do, actually.
Yeah, you just need the SIM card reader and a test SIM card that you can buy it off
But
eBay or
this
something.
way, this is not safe. We can use this.
Yeah,
It's all our problem.
One thing I've noticed about the difference between FlexRIC and OSCRIC as well is whenever you're talking about writing an XF for it, they do provide these sample XFs for FlexRIC, but they're very like small scenario that is scripted. So they'll script with their SDK a certain scenario, but the idea is that you would take this and implement your own scenario. Whereas like in OSCRIC, the XF will just continue to run and do its functionality generally. You know what I mean?
yeah.
Like
What do you mean? I don't, sorry.
it's like more like a Python script that they're calling in this library function to just provide you some demo
Oh, I see.
of their functionality, and they say, okay, well, you take it from here from us
Then
and do
you write
whatever
your
you
own
want.
as opposed to
Exactly.
the
Yeah.
other one they give it. Yeah.
And OSCRIC, it
Makes
just
sense.
continues to operate like it really would.
Yeah.
Yeah.
It makes sense because the OAIC is meant to work to be deployed by
Yeah.
the big guys.
Yeah.
Absolutely.
So what they want to do is they want to convince people, right, that this works. For these people, it's more like it works. We just give you the messaging
Well,
framework.
for us, this is perfect.
Yeah.
Because we just want to. I mean, basically, what we're doing, like most, I should say most, but most universities they just use simulation with
Yes.
simulators.
Yeah.
But in our case, we want to take one step further, make some experimental data.
Yeah.
That's where we can go. So that's really
Yeah.
we don't care about.
Yeah.
It's perfect. No, this is good.
Yeah. I think when we're talking about 6G adoption of some of these ideologies in either ORAN or FlexRIC, it's probably going to be somewhere in the middle of both FlexRIC and OSC.
Yeah, and there are
Because-
different research areas, right? I mean,
In the future, we can have a lot of private networks. Small
yes.
Yeah. Who cares? I don't give a shit.
Yeah.
Yeah.
You know?
Mm-hmm.
Yeah, it depends on scale, right? If it's a small private network, it doesn't matter. Yeah, it's okay. It can handle the load, right? And you can have one guy managing it. But if it's like hundreds, then you'll need to have the.
Yeah, you're right. It's only the commercial networks that you want to maintain that through GPP
Yeah.
alignment.
OSC's main this thing is that their main focus is that they want to show that even with all these overheads that Docker brings in, Kubernetes brings in, I mean, it's all a layer, right? And there will be some latencies involved in that. And that will affect the timing requirements. So they want to show that, okay, even with all of this, it is possible to kind of do it, right?
Other than the disaggregated front haul, it's really not in the discussion as far as an alignment with the third GPP specs,
Yes.
because everything they're doing with the RIC is, as far as I'm concerned, is the real value
Yep.
add of ORAN
Oh, yeah,
itself.
no, it makes sense. The question I have, which I think we brought it up or somebody is, are the people who are making the use of the CPUs, because right now, as you said, you're just giving them an advice what to do. Are they going? Do they understand what you give
Yeah, I'll
them?
just get back.
So what I did, so I can edit here. So I type here, before I did here. I call it something called programming. It's my research that I do. And that's the idea is that you can, because all it does is it takes this and brings this comment as if they're marked. So yeah, so you can, of course, the nice thing is I have like an editor, so I could, I pick something and make it bold. And I can underline, and I can insert hyperlinks and things like that. And then automatically it goes as far as done. And I could also, I can change things if I prefer, I can type here, that's a courier style.
Or you guys?
So notice the data. So again, and here's my, this is correct syntax, insert PNG file. So I can just tell you, but I can't see it here. I can't see it here. I can put in flow charts. There's so many communications. Oh, here's the Docker pod. Oh, it would be nice to have that next. So anyway, this is something I
Yeah. So
Okay, so we are starting. Thank you.
yeah. Let's run the RCX app first, and we'll see what it's doing, and then we'll make modifications. So yeah, this is the function which okay. So we'll instantiate the G0B and the UE.
Are we following the directions? Which directions are we currently looking at, or is this?
No, we have reached the end almost. So of the directions.
Okay.
So
Now
we'll
we're following you.
yeah, you're gonna follow me.
One of the challenges for me is it's hard to see the screen.
Oh.
Or in other words, the bottom of the screen.
Bottom of the screen.
Oh.
And I thought perhaps you could resize your window so it's at the top.
Yeah.
Yes.
Yeah, that will be.
Something like that helps me.
Yeah.
But in Windows, that is dark.
Yeah.
Is
So there
that
are different terminals. So if you can tell people which window, which terminal, right? Some is UE, some is GNB.
yeah? I will. It's the same as what you did with the KPM XApp, but instead of that, you run the next command. There is another command here, right, for XApp KPM
So
RC.
they can pick any window and restart.
No, use the same windows that you used for GNB, UE, and the FlexRIC.
Okay.
So let's say terminal 1, you instantiated G0B. We'll again do that in terminal 1. In terminal 2, we'll instantiate the UE.
So they can follow the previous command.
Yes.
That you have done.
Yeah.
So only those two things?
No. And then FlexRIC.
FlexRIC.
I'm just giving them some time to. And then the traffic. So yeah, you have to have GNB, UE, FlexRIC, and traffic. 1 second.
Then you did one more after traffic.
Yeah, but I'm not getting traffic. Just a second.
Is this the downlink hyper or the uplink hyper?
It doesn't matter. You can do uplink or downlink. Yeah.
Also, we need to run access first.
For this, it doesn't matter. Traffic, even if you have it, or you don't have it, it doesn't matter. Yeah, let's not do traffic. It's fine. Yeah. Yeah, no need for hyper. Yeah. We'll keep it simple for now.
So GNB, UE, and FlexRIC, only 3 things
Yeah,
are equal.
just 3 things. The core, yeah, that will be running in the background. Yeah.
But you have to restart, or it is already?
No, it keeps running in the
It
background.
keeps running.
Yeah. Yeah. So now we will instantiate KPM RC XApp. So this XApp includes both the key performance metrics monitoring, and RAN control functionalities. We will go inside and see how that looks and how they have coded it and what we can do to kind of modify it just a little bit. But our main focus today will be on the RAN side. The modifications that we do, we will do it on the RAN side.
And this was that last two instructions in the file, correct? You just ran
Yeah, the last the last instruction.
the last one.
Yeah.
The last two.
Yes, yeah. So after it has run successfully, just close your UE and the Gnode B so that we can view on the terminal as to what has happened. Otherwise, it's difficult to track it because it keeps on giving more data. So is everyone done with it? Okay. So on the UE side, okay, first on the XApp side, you will see that there would have been about 100 messages. So these are basically the indication messages that the KPM XApp has got from the RAN. So morning, Nathan was telling you about the KPM messages. They are basically indication report service messages. And now we will see the control message, the RC control message. So here, since we didn't have much traffic, it's showing zero PRBs, zero data rate, and very minimal number of PRBs. So these PRBs are so this is being tracked a bit more in a bit more fine-grained fashion. So the frequency is more. So that's why you see quite less number of PRBs being assigned to the UEs. I mean, it's not at the slot level, but yeah, a little more fine-grained than what we saw earlier with just the KPM XApp. At point around 50, the 50th mark, you will see that the XApp has a message saying it has received control acknowledgement. So it would have sent a control request around the 49th mark, 48, 49, depends on the performance of your system. So that's what you can see at the XApp side. Now we will go to the UE side or the GNB side, sorry, and you will have to search a bit here. Just a second. Yeah. So you will see that you will see some messages here saying that the E2 agent at the RAN at the Gnode B has received the transmission control message transmission from the near real time RIC or the XApp, and it has acknowledged it. So that's why you see the acknowledgement received on the XApp side, and it has printed some values here. So it's saying QoS flow mapping configuration, and DRB is data radio bearer. So some IDs and some QoS flows. So and the quality of service, so QFI, right? The quality of service indicator. So that is it's hard coded basically, which we will see that in the code. And direction is the flow of traffic. So whether it's downlink or uplink. Here it was mainly the UE maintaining the connection with the GNB. So it says 1, 0 is downlink. You can play around with this. You can simulate downlink traffic and see that it outputs 0. Yeah. So is everyone able to see this in their terminals? Anyone who is not able to see this? Yeah. No, okay, you're searching. I thought it was going on. Wait, is it still running?
Yeah.
Oh, no, close it. It would have disappeared. So as soon as the XApp ends, forget the, as soon as this ends, close the GNB and UE connection and then scroll up. It will be easier to find. Because it's updating at a very fast pace, right? So it's difficult. Yeah, now you can bring the UE up. Close it. Control C, yeah. Do you have the UE up?
Yeah, it's all.
No, you have to instantiate it. Yeah, now initialize the XApp. So go to the UE, go to the UE. Okay, check where it is. Okay, yeah, go to the UE, close it. Control C, Control C. Go to the GNB, close it. Okay. Yeah, now scroll up. Up. Yeah. Yeah. So let's see what's happening inside. So is everyone else able to see that? Okay. So let's open. Just keep up with me because this can get a bit confusing if you're not used to this. So go inside the OAI directory. We'll be using the GUI for this, so that it's easier to keep up. And sorry, go to the FlexRIC directory. Examples, XApp, C, and KPM-RC. So you can see the path here above. And open the kpm-rc.c file.
Yeah, so what application did you use? Some browser or something? Yeah, what is
This is gedit. It's a text editor.
Oh, no, the path is in Windows Explorer or?
No, this is Ubuntu's Explorer, File
Yeah, so
Explorer.
how do we get it?
It's here on the side, files.
It's a
No, it's just a VirtualBox virtual machine.
Yeah,
Oh, you're okay. You okay? Fine. Yeah. Well, let's do it in a terminal. That's okay. So go to FlexRIC. Examples, XApp, C, and KPM-RC. So this should be the directory. There's only one file inside. XApp kpm-rc.c.
So then we open that in text.
Yeah. You can use Vim. We would have installed Vim, so, or you can use Nano if you're whatever you are comfortable with. But let me use the GUI text editor so that I can just explain it to you, and the modifications I'll make in Vim, so that you follow along with me. Yeah. Okay, yeah, before I go there, so you saw the exchange of E2 messages, right? But I don't think you would have seen like what the E2 messages actually look like, unless you're familiar with how 3GPP and ORAN Alliance work. It might be new to you. So I just wanted to show you a Wireshark capture of the E2 packets. So this I had done in my free time, so on my own time. So just if you want, you can do it in your time. It shouldn't be hard. I can post the instructions, but in the interest of time, we are not doing it in this session. So basically, this is a setup request, and so you can see that it's a setup request. And there are different fields here. So there are different items. Some of them have not been encoded properly. That's why they show up as unknown. And here you see the global E2 node ID. And here you see the value associated with that item. So it's basically like a key value kind of pairing. So here it's saying it's the GNB, and then within that you see the GNB ID and the GNB ID value. So it's a nested format. So this is basically ASN1 encoding. So that's what the ORAN Alliance also uses. Similar to JSON, very similar to JSON. So if you have experience with that, you'll be familiar with this. And the yeah, so a setup response basically shows that okay, it's category E2 setup, and you have a setup response for the RAN ID that you first registered. Yes, another thing is the setup request also has RAN functions included. Here we don't have any. I did it quite some time back. But yeah, if there are any RAN functions, those RAN functions will be accepted. Oh, I see a RAN function accept here. So yeah, maybe there were some RAN functions at that time. So the RAN functions are basically, where is the VM? Yeah. Yes, what you saw here, right, in your FlexRIC near real-time RIC terminal. So E2SMRC, KPM, these all represent the RAN functions. Okay, so now I'll just go through the code for this. We won't be making many modifications here, one or two, maybe one. But then we will go to the RAN side, which is a bit more complex. So I just want to cover that in a bit more detail than this. This is pretty simpler to understand. If you know C coding, it's pretty easy to understand. But I'll just go through it. So basically what's happening here is, as you saw in the name, it's called KPM RC. So it includes both KPM functionality and RAN control functionality. So this is how you initialize the XApp. There's an API for it. So you basically call that API and pass any arguments that you might want to give to your XApp. Now this is very, very similar to what you did with the config file. So when you were working with the OAIC, when you had to deploy an XApp, you had to pass in some arguments, and those arguments came from the config file, right? So here you don't have to do all that. You just normally, how you do it normally, you just pass your arguments as C arguments when you're executing the program. And that functionality you can define. It's basic C programming. So yeah. So basically here you're defining the E2 nodes by calling this, registering the E2 nodes by calling this API, getting which nodes are registered from the E2. So in OAIC, you had the E2 manager, which maintained the status of each RAN node. Here also you have a similar entity. So this function, yeah, E2 nodes XApp API, that helps you get that information. So after that, basically you define a handle. You define a handle for the XApp, for the services that the XApp needs to execute. And this is where our KPM, key performance metrics handle starts. Yeah, so basically some RAN nodes might offer KPM functionality, some might not. So you search through all the different nodes that you have in your database and see which of them support the KPM functionality. And so that's what you're doing here. Find service model index for each of the RAN nodes. So you're going through the nodes here and checking if they have the KPM service model index. If they do, if they do have with not null means that they have the service model and the associated functionality, then you generate a subscription request. So this is the function gen KPM subs, right? Basically, you're generating a subscription request for a particular RAN ID and then sending it. So to send that subscription request, you just create a report handle and then yeah, and then send the subscription request. So basically what this does is once you do this, the subscription manager will send the subscription request to the RAN, and if the RAN accepts, then it starts sending data, right? And this particular handle will keep listening for incoming messages from the RAN, and then it gives you the KPMs. It decodes the messages and gives you the KPMs. Now, yeah. So here you see SMCB KPM. That is basically a service model callback, a callback function. So you have referenced this here so that the handle knows where to route the messages and which function has the capability to decode the incoming messages. So that's what you're indicating here. Yeah, let's move on to the RAN control, and we will go into a bit more detail on this. And it's designed very similarly. So once you know one of the functionality of one of the components, you can easily figure out the functionality of the rest. Any questions? Okay. So again, here you are doing the same thing, going through the nodes and see which of them offer a RAN control functionality, or which of them include a RAN function definition. So if they don't, you don't do anything. But if they do, then you send a control request. So to send a control request, you first need to generate the control message. So this is what the gen control message does, right? So it's basically defining a control message for a particular RAN ID. So this is responsible for interacting with the IAPS, the E42 interface, this control SMXApp API and report. Yeah, report SMXApp API. These are responsible for doing that. Note that you are not defining a handle here other than the acknowledge, which is handled by the subscription manager. Because once you send a control message, you're not expecting the RAN to give you any reports, though you can configure it to do that. That is possible. Yeah, it is done here actually. So no, it's not done here. So yeah. Okay, so let's dive a bit more a bit deeper into this. So let's look at the gen control function. Okay. So here you can see that yeah, here you can see that yeah, before this, let me explain a bit more. The RC service model was designed so that you don't have to keep defining service model for each functionality that you want to implement, right? Or you want to control. It might be traffic steering, or it might be admission control, or if you may want to just differ the scheduling policy that is being employed. So before the RC model was adopted, you had to define your own specific service model for each RAN functionality. RC just combines all of that into one single specification. So using the same metrics and the same nomenclature, you can now control multiple different RAN functionalities. It can be traffic steering, scheduling, or maybe admission control or anything like that. So all of this is included in the specification document called E2SMRC. So this is the version 1.03 that now there are actually, I think, 5 or 6 versions, but this is the version that FlexRIC has implemented partially. Now this is a very huge specification document. So you can see the type, yeah, here, right? You can see the type of services that are offered by the RC service model. So it can be report service or insert service or control service or policy service. There are 4 types. Now they have defined a couple more services, I think 5, but yeah, these are the 4 main services defined for this service model. And yeah, there is a function description as well. So here, yeah. Yes. So there's a function description as well. What this does is, yeah, let's go to control. Yeah. Yeah. So the control service offers radio bearer control or resource allocation control. So these are the different types of control functions that you can expose from your RAN. Or dual connectivity, whether you want it to be connected to an ENB or a GNB or some other type of network in the future, or carrier aggregation. So these are the control. So this is what is defined as styles, right? So that's what they call as styles. In this particular example, we'll be using style 1, which is radio bearer control. Now, radio bearer control is an umbrella term that is used for multiple sub-control mechanisms. So it can be modifying the QoS parameters of a particular DRB, or it can be to map a QoS flow to some other ID or some other DRB, or it can be for admission control. So these are the services within radio bearer control that are offered within the service model. And we'll be looking mainly at these. So let's, and you can see that that has been defined at the top. Yeah, you can see that that has been defined here. So basically, RIC control service style 1 is being used, and in that service style, these are the services offered. So what you might see that all of them are being assigned a number. Basically, you're listing it out in an enum data format. The reason for doing that is these names are going to be constant. So when you're sending a message, right, you want these exact names to appear so that any RAN node can understand it, regardless of who is selling it, right? That's where the openness aspect comes into the picture. If you have a different name, right, even if it's off by a number, then your conditions are not going to satisfy, and your RAN is going to misinterpret that message. And that is why this is kept constant. But now you can use in your implementation any number that you want. No, you can't use that. That is also kind of standardized. But in your implementation, you can refer to it in a different format, in a different. Doesn't matter whether it's C, Python, or some other Perl, some other language. Doesn't matter.
Is this the nomenclature as defined in the standards?
Yes, it's as defined in the standards. Yeah. So here you can see that. Let me give an example. You see 7621, right? So what that basically means. Oh. So what that basically means is 762. go to the specification document and yeah. So service style 1 is defined with control service style 1 is defined with 7621 for yeah, this all these.
So I think immediately, since these documents are constantly updated, then these sections might not stay the same. So if that name is associated with where you can locate this within the standard.
Normally, the way 3GPP and these people are also follow similar approach, they add new things. They do not
Change the
old-
existing.
Okay, so
Meaning this section number will remain the same. They will add something more.
I see. So
Yeah.
they won't say, oh, this needs to go before this, and therefore.
No.
No.
They always add things, but do not.
Okay.
Yeah, like void, exactly.
Right.
Yeah.
That makes sense.
Looks like he has looked a lot of specifications. Yeah, void. They will put void. Yeah.
Yeah, and you see that each of them have their own numbers, 8421, right? And that's the same as what is offered here, 84222. Yeah, let me go back. Yeah, so this is for QoS mapping configuration, and what they have here is again for QoS flow mapping configuration. Now, if you go to that particular section, you will find the same numbers associated with those variables, with those enums. So that's how they keep it, standardized and interoperable. That's how interoperability is achieved. Yeah. So we don't have much to discuss here. We'll modify just a couple of things. Now, okay. So all of these parameters are defined according to the specification, right? Let me go to the 8422 part. It's easier. Yeah. So for the QoS flow mapping configuration, the specifications say that it should have a DRB ID, and that is mandatory. It's a key flag. Then you need to have an identifier and the mapping indication, and the same. So you have different fields for different types of messages, for different styles and different actions. So yeah, now you need to populate this, right? So that is what is being done by the fill QoS flows parameters. So if you can see here, they're all basically structures, and you define them in these structures. So you have an ID, you have what type of value is it bool, is it integer, whatever it is, and then you have the size. You have the size of that particular value defined, whether it's 2, 4, 8. So you need to define that as well, and then you will have the value associated with that particular parameter. So any questions till this point? Okay. So yeah, let's modify a simple parameter. So the thing is, this looks complex, and it looks as if it's impossible to go through this or make some modifications to it without breaking anything. What you can do is use the existing data structures and just modify them, but you interpret it differently at your end. So it might not be, let's say you are representing RRC state without actually encoding this. You can encode the RRC state in, let's say, this parameter, the one which represents 10. 10 was basically QFI, QoS flow indicator. So you can modify this and then have that reflect in your RAN system, and then based on that you can modify your application, right? So we'll do this because if we have to develop our own custom service model with all the parameters listed according to standards, it's going to take forever. We'll need to do a week-long workshop, not a 3-day workshop, 2.5-day workshop. So yeah. No, it's pretty simple. It's not It's not that complicated because most of it you are reusing the styles and the actions you are reusing. The only data structures you would have to modify are these. So this, and filling up these parameters, right? These are the things that you would have to modify. Should be a day or two if you sit at it. So yeah, but it's just the repetition of the same thing that you're doing.
Should include in this where you can find like a reference, like what standards you can reference.
Oh, it is there.
Oh,
Yeah, see, structure, mandatory RAN parameter structure 9.3.12. They have given some comments. And
This is originally what they were provided.
no, this is what OA. No, no, no.
They added, right?
Yeah.
They provided.
Yeah, I didn't add that.
this is working group. Is this working group 3? Like,
Yeah, no. The specifications are defined by working group 3. This implementation has been done by OAI. Yeah. So they are just referencing that specification and saying where this particular structure, because that's a pretty huge document, right? So they're just given some comments as to where to look for it. Yeah. So yeah, let's modify this. Okay, I'll go to Vim for this. Yeah. So let's go to line 285. And make this 1. And then write it out. Yeah. So this is the file. Okay. So this is the file path, and kpm rc is the file. So go inside and go to line 285. So you can see the line number at the bottom right corner, and it should have a value of 10. Modified to 1. Is everyone with me? Okay. So once you have done that, save it. So what we are attempting here is we want to release the connection of a UE. But now how do we know which UE, right? So we are hard coding that UE identifier. So we are saying let's release UE1. So that's why I modified that to 1. If you wanted to, if you had multiple UEs, let's say 10 UEs, and you wanted to modify, let's say 5th UE, you just encode it as 5. Or you can have a logic, right? Depending on the logic, you can say which UE has to be modified.
Does anyone need help modifying that site?
Yeah. So once you modified it and once you saved it, we just have to build it again. So go back to the FlexRIC building instructions, and before you follow that, delete the build folder. So within FlexRIC, if you do ls, you will see build. So just delete it using this command, rm-rf. Okay, and then you can follow the build instructions again. Yeah. So let me know when you have gotten to this point. Anyone stuck at any stage? Does anyone require any assistance? Okay. So next we will modify some functionality in the LAN. So this might, yeah, so just keep up with me. Is everyone good to go? Okay. So let's go to OAI. Yeah. So this is the path that you have to go to and open sorry. Yeah. Open ran function rc.c. Ran func rc.c. Is everyone with me? Okay. Yeah, I'll again use here. It's easier. So we want to modify the RRC context, the UE context, so that we can do by issuing an RRC release that comes from the GNB. But that directive for the GNB comes from the XApp. The GNB can decide not to comply. So, but here we force the GNB to comply. Yes. So open the ran function rc .c file. Now this has, yeah. So does anyone have any question? So this has a couple of methods. We will again track that from the beginning. So whenever, so this offers, as I said, two functionalities. One is reporting service and the other one is control service. So this is actually reporting if to the near real-time RIC or to the XApp if there is any change in the RRC status. We didn't see that, but there is another XApp that you can run which shows that. So let me see. So you go to FlexRIC, examples, RIC, sorry, examples, XApp, C, and monitor. So here you have XApp RC monitor. So that basically tracks the RRC state change. And KPM also KPM RC XApp also tracks that, but we didn't go through it. So yeah. Anyway, so so whenever a control request comes from the RIC, the write control function here is called write control RCSM. And this basically populates the data fields from the control message. So here you have a header which is decoded, and then you have the actual message. So each control message, or any message for that matter, E2 message has its own header and the actual message. So the header defines, okay, what kind of format or what kind of style is being followed, and the actual message represents the data that is being encoded. It can be as simple as a single parameter, or in this case, that list that we saw, right? And there are optional parameters and mandatory parameters. So if you're developing something according to spec, you will have to follow that. But if you're not, if you're doing something for research purposes, right, where it doesn't need to be according to spec, you can either define your own custom service model, which is much simpler than this, or you can define, or you can just use some of the existing service models. So here, yeah. So here we'll have to make some modifications. So just bear with me. There are a list of files. There's actually one file that you will have to go through to issue the RRC release control command. So let's see. Now you don't have to look for it because I already have. So I'll just tell you where it is. But if it's any other function, you will have to look for it in the RAN. You'll have to find out, okay, where is this? Let's say you want to change the maximum number of times DL hark is done, right? So now you will have to find out, okay, where is this parameter being set, and then you will have to go there and get the parameter to kind of modify it. Or let's say if you want to change the MCS, right? You will have to find, okay, where the MCS is being updated, get the parameter, and then change it. So here this is an example for RRC change. So this particular, okay, let me open in another terminal window. So RRC folder is within, yeah. So within OpenAir 2, there is RRC, and then there is NR. Now there are different RRC messages that have been defined for the GNB and the UE. Simply NR indicates the GNB messages, and RRC GNB ngap.c. So basically, the RRC's interaction with the ngap is being defined here. Ngap is it connects to the core network and the traffic basically. So yeah, let's open this. So in case you don't want to make these modifications, there's a separate branch. Let me just show you that. So go to our GitHub repo, and within OAI, OpenAI Cellular, and OpenAir Interface 5G. So you checked out V1 version. Sorry, zoom in. Okay. Okay. Sorry. So yeah, you can search for the branches here. Yeah, so there is V1 and V2. V2 has all the changes that you need to make in the ran function rc.c file. But yeah, I just thought we'll get a bit more hands-on, so we are not directly compiling it from there. Okay, let's get back to this. Yes, so open rrcgnb ngap.c in a different terminal window. So you can just copy paste the same code from here to the other side. That's why I'm asking you to have two terminal windows. Let me just move it side by side. Or if you have tmux, then it's even easier, right? You can just have them side by side. So yeah. So this is the function which is our guideline to implement RRC release. I'll quickly go over what this function does, and we can just implement the same functionality in our E2SMRC file, the ran function RC file. So here we are getting the ran context. So there can be many gnode Bs defined within the same instance. So here we have hard coded it to get the first gnode B instance, and we are assigning it an ID which is 0. No, here we are defining the UE ID. Yeah. And then, yes, here we have to get the context of the UE. So here, so basically what happens usually is the AMF or the core network issues a command to the GNB to say, okay, release this particular UE, right? But here we are not doing that. The core network is not being involved. So the message is coming from the RIC, but there is no way to kind of emulate the message. So we are hard coding it. So we got an instance of the GNB and a UE. Now this particular UE ID is what we get from the near real-time RIC. We encoded 1, right? So when we call this function, when we call this functionality, when we code this functionality in E2SMRC, we can include that argument. So basically, once you get the UE context, whether it's connected or if there is such a UE existing with that kind of ID, then you can go ahead with the release. If there's no UE, then there's nothing for you to do, right? So if the context is null, then there's a warning message, and it just says it's complete. But we won't be touching this. We don't need this. It's okay, because we know that the UE is connected. And this is just an example. You can again modify according to your requirements. So yeah, so once you have the UE context, yeah, ignore this. This is for the report service that I was talking about, that if the RRC connection releases, that the RAN can report it. It's for that, but we don't need that. Yeah, it's just we are almost at the end of it. So if a UE is associated with a CU centralized unit in the user plane, which it might not be, because a UE might not have connected properly, or it might be idle, or it might not have acquired a PDU session. So we don't bother about that because we know that the UE is connected. So we go directly to the main functionality here. So basically, we see if the UE exists at the DU using the F1 interface, F1 APIs, and then we get the context, and we set the context of that UE to 0, which says, okay, it's going to be released, and then we release the UE. So we will have to call this function at the end. So let's just code that. If you want a reference, you can go to that GitHub page that I showed. So go to OAIC Workshop V2 branch and open it. Yeah, in OpenAir 2, E2 AP, RAN function, ORAN, and E2 SMRC, RAN function RC. So here you can find the changes. If you look at the commit difference, then you can again see what the changes were. That becomes easier. But for the sake of time, I'm going to tell you what I changed. So I just included a header file at line 29 and then implemented whatever functionality was seen at the very end here. So just scroll all the way down and the function, the last function, you see the right control RC service model function. So here you scroll down, yeah. So this was the parameter that we had encoded in the FlexRIC's XApp, and that is what we'll be using. That was actually the QFI, QS flow identifier parameter. So now we will just consider that to be the UEID, and then implement the logic that we saw in the other folder, other file. So you can either just, the easiest way is Control A and Control C and Control V. But if you don't want to do that, if you want to follow on, then you can just code along with me. So let's include the header file. So it's going to be this one, GNB UE context, because that's what you want to know, right? I'll just copy paste from here. And then just go all the way down. And implement the functionality given here. You can just search for it. Yeah. Yeah. So you'll have to keep in mind some of the structures that are being used. So there are some special structures that OAI has defined to denote the UEID. It's called, yeah, I think it's UEID T. Yeah. So you'll have to make sure that you don't mess up the data types. Yeah, let's just copy paste in the interest of time. So basically, you are assigning the QFI value, which now you consider as UEID, to a variable called UEID. Yeah. Let me know when you guys are done. So basically what we have done is, yeah, got the RAN context, the UID we got from the RIC, and then we set the UE context to 0, which means it's getting released, and then generated the RRC release command.
So it just releases one UE. Could you set it up to?
Yeah, it depends on the logic of your program, right? You need to encode that many parameters at the XApp side, and then decode those parameters, and then give that as the input to have a for loop or something like that to go through it. But yeah, it's easy. Yeah, it's pretty much easy. You just need to have a for loop and then go through the UEIDs. Yeah. So save this.
So like this, something like this would be useful in the sense of, because you were saying the AMF sends it, like typically what happens is the AMF would send a message to the Gnode B to release the UE. But in this case, since we're not using the AMF, we're using the RIC to issue that.
Yeah.
I'm thinking a possible reason for using the RIC over this would be in the case of like,
Yeah.
if there was like a malicious UE or
Yeah.
something like that.
Yes, you can do that.
Okay.
Yeah. Yeah, there are various applications for it. I'm just covering the methodology that we employ. Yeah, so save, and then we need to build OAI again. So does anyone have any issues? Does anyone need any help? Okay. Yeah, so again, to rebuild, you will have to delete the build folders. Here it's called ran build, and the log. It's okay if you don't delete the log, but yeah. And again, execute the compilation command for the OAI setup that you can find here. So the last command was the build script. So yeah. Does anyone have any questions? Any issues?
I do not know how many you have survived. Yeah, we are reaching the end of the day.
Yeah.
All kind of memory is getting full.
Yeah.
I'm surprised my computer hasn't exploded yet.
But if you need help, feel free to raise your hand. If you have that much energy left, to raise your hand. Any questions?
I have a random question.
Yeah, sure. Yeah.
Before we changed before we made the changes for the rank function, like the QOI thing, was that even doing anything, or was it just setting a variable? And like keyword.
Q.
Like when we, I guess QOS, like
The QFI.
Yeah, QFI. Yeah, you change.
Yeah.
Actually being used anywhere.
Yeah. In this version it was not being used, but there are versions where it's being used to kind of map the flows and generate new flows, new DRBs, data radio bearers, for a particular UE connection. So you can do that as well. Just that this was the simplest one I could find, so I did this.
So something that was not used, so it's good to overload that and use
Yeah,
it for other-
yeah.
Okay, good.
So once it builds, we'll just run it and then, yeah.
So it's probably a dumb question, but so instead of, is there a way we can set this up to where we, if you wanted to like cycle through a value, so you're changing something, therefore you have to recompile. Is
Yeah.
there a way so we can set this up so we can kind of cycle through values without having to recompile every time, like just in a more automated fashion, or just
Yeah, you
kind of
can.
like implementation?
You can automate it, and actually, yeah, I should have done that. There is
I was
no, there is an option to just recompile the GNB part or the UE part. So it's just another argument that you need to add to your build command. That they have that functionality, and it's faster. It's going to get faster. It's going to be faster, right? Using that, because it's not, you're not compiling the whole thing. The ENB, the LTUE, NRUE, so it's compiling everything. But yeah, I should have used that. But yeah.
Again, I'm just wondering, just for like the capability.
Yeah.
So you will show us that we
Yeah.
are releasing that connection.
Yeah. I'm just waiting for it to compile.
So there is some timer after which you will release the connection.
No, when we execute the XApp, right, that will automatically send a control request, and according to that, this will release. So it's dependent on us when we want to issue that control
Oh, I
request.
see. So as soon as you
Yeah.
execute the command.
Yeah. Yeah. Thankfully, I don't think I've done any mistakes, so we should be good. So now we will just run everything again.
Oh, we have to start all the terminals.
No, I just wanted a fresh terminal, so yeah, you have to start the GNB UE. Yeah. Yes. So these two are going to be my GNB and UE terminals. This will be my near real time RIC, and this will be my XApp. So yeah. So Yeah, so the GNB is connected to the FlexRIC module, the near real-time RIC, and the UE is connected to the GNB. Now let's see. Hopefully this works. So at the 50th second, the control message is sent. Yeah. So yeah. Yeah. So at the 50th iteration, the XAP sent a control transmission, and the RAN received that control transmission. And you can see that it says RRC release triggered for UE1, and it is acknowledging the control message. And then for that, then it has translated this UEID to the RNTI and is releasing the context, UE context, and the PDU session. So, but what happens is at the UE side, you can see that, okay, this is resynchronization. Yeah, you can see that the UE receives the RRC release from the GNB, and it's moved to idle state. But then it starts looking for the looking for another GNB again, and it latches on to the one it can find. And that's why you can see that, okay, it again finds a cell and again performs ratch and synchronizes with the GNB and then gets connected, and then you again have a connection. So yeah, any questions? Anyone need any help with running? Okay.
Is that the final thing?
Yeah,
Right?
yeah, yeah.
Okay,
I mean,
yeah. So thank you for surviving